All right, so as requested, we are going to be going through how to solve questions involving frictions on a flat surface. So the common example that you will see is you always have a car moving around a roundabout, all right, or some kind of vehicle. So the question that we need to ask ourselves is, how do cars travel around a roundabout? Like, what provides those kind of forces? So if you think about it, when a car is turning, what are the wheels of the car doing, right? That's what we got to be thinking about. So when I turn the wheels here, so these are my wheels, the red lines, right? If we turn the front wheels, can you see how the front wheels are going to propel the car in a sideways direction, kind of like this, all right? And so you can imagine that if the wheels are rubbing against the floor, it's going to produce two kinds of forces, right? So there's going to be one that's going to push the car forward, and it's also going to be another one that's going to push the car sideways, okay? So these sideways forces, we call these lateral forces, okay? Lateral means sideways, okay? So when a car is turning its wheels, these sideways frictional forces, right, is what turns the vehicle. It's what's responsible for allowing the car to travel around a roundabout. So for example, if we have, if we draw a diagram, a top-down view here, so here's my circular path, my uniform circular path, here's my car, right? The force that is responsible for keeping an object or pushing the car towards the center is going to be the frictional force. Okay, as long as you understand that, we are good to move on. So to summarize, during motion, a vehicle does not experience typical resistive forces like the ones you saw in Module 2, okay? Instead, vehicles experience what's called rolling friction, right? And rolling friction is effectively zero, okay? However, when we talk about rolling friction, we're talking about the vertical components, right? So the vertical, okay, don't worry about that. But essentially what we're saying is that this is what we want, okay? We want the frictional forces to the side, and these sideways frictional forces is what's gonna affect the object. Okay, so when you turn the wheels of a vehicle, the wheels push against the car sideways, producing a lateral force, turning the car. This sideways force comes from friction, and it's also known as lateral friction. Cool, so now that we have established that the frictional force is responsible for turning a vehicle, we just gotta understand, okay, well, we know it's friction, but how much frictional forces are being generated? Well, remember, in Module 2, we learned that the frictional force is given by the formula mu times Fn, okay? Where mu is a coefficient of friction and Fn is the normal force. Okay, now the normal force, to find the normal force, all you have to do is you draw a free body diagram. So let's say a car is traveling on a flat surface. So when you have a flat surface, what forces act on the object? You have the normal force and you have the gravitational force, okay? So as you can see, because we only have the normal force and the gravitational force, your normal force and your gravitational force cancel out. So essentially, your normal force on a flat surface is effectively always just going to be equal to mg, all right? So because we're dealing with flat surfaces only here, we're just going to rewrite it as mg, okay? So how do you actually solve frictional force questions on flat surfaces? The rule is this. To solve vehicles around circular path questions, you have to ask yourself the following three questions. Number one, okay, how much centripetal force is required to maintain this motion, right? Because if you think about it, every circular path is defined by, because it's uniform circular motion, we can say that the net force must be equal to mv squared on r. So uniform circular motion is defined by this equation. That is to say that if I want an object to travel around a circular path, we need the force to be equal to this amount. Got it? So in other words, this is the force that we need. Okay? We need this amount of force. Okay, cool. So the question then becomes, okay, well, how much forces do we have? Remember that the wheels provide the lateral frictional force. Okay, the wheels push the car sideways, right? So we ask ourselves, okay, how much frictional forces do I have? So this force, the frictional force, is how much we can, how much force the car can generate from its wheels. Okay, so this is how much you need. The centripetal force is how much you need. The frictional force is how much you have. And then all you have to do is you ask yourself, okay, we need to compare the two. If the frictional force is larger than the centripetal force, we're saying I have more force than how much I need, correct? If I have more than how much I need, the car can make the turn. True? If the frictional force is less than the centripetal force, the car's going to skid. So you're always just asking yourselves, do you have as much force as you need? Yes or no? And then that's your answer, right? If you have more than how much you need, you can make the turn. If you don't have enough frictional forces, the car's going to skid. You're going to hit a tree. And guess what's going to happen after that, right? You might be going somewhere else. Anyways, so that's how we deal with frictional force questions on a flat surface. You just ask yourself how much you need, how much you have, and then you compare. Okay, let's have a look at an example. Question number 1. A young teenager, her name is Charlotte, just got her P's and wants to show off her new car to her friends. She is driving towards a roundabout, or around a roundabout, at 60 kilometers per hour. Riddy estimates that the roundabout has a radius of approximately 15 meters. She uses what she has been taught in physics and claims, so Riddy claims that the car will not be able to make it around the turn. Okay, given that the coefficient of friction is 0.8 and the mass of the car and its occupants weigh 1,500 kilograms, part A, determine if Riddy's claim is correct. Prove with calculations. So we need to calculate or prove whether or not this car can make the turn. Okay, so let's start by listing out our variables. All right, we know our velocity is 60 kilometers per hour. Right, we convert that into meters per second. What is that? I think it's about 16.7 meters per second. Cool. All right, what else do we have? We know that the radius R is 15 meters. We know the coefficient of friction is 0.8, and we also know that the mass of the vehicle and its occupants are 1,500 kg. Okay, so remember, what we are trying to do is, we are trying to determine if the car can travel around the roundabout, right? So let's draw a diagram here. Okay, so we know it's going to be uniform circular motion, right? And how do we define uniform circular motion again? We say that the net force must be equal to mv squared on r. Okay, so remember, what force provides the centripetal force in this case? It was the frictional force, correct? Exactly, yeah? So we need to check, do I have enough friction to maintain the circular path? Okay, so let's do the check. How much force do you have? Okay, so frictional force is how much force we have. Okay, so how much force do we have? It's going to be mu times Fn. Remember we said Fn is mg, right? So mu, which is 0.8, times m, which is 1,500, times g, which is gravity, 9.8. Okay, so how much force do we have? Let's calculate it. Okay, so I'm going to put it into the calculator. Let's see what we get. 0.8 times 1,500 times 9.8, and as you can see, we get 11,760 newtons. So what this means is this is how much force the car can generate from its tires. Yeah, now we need to check how much force we need, right? So the force needed, remember, that's provided by or that's determined by your centripetal force, correct? So that's going to be mv squared on r. Okay, and let's plug it in. So again, that's going to be 1,500 times V. V is going to be 16.67 times squared divided by R, 15. Okay, so what do we get here? When we plug in the force we need, let's check what we have. So 1,500 times 16.67 squared divided by 15. And as you can see, we have 27,789 newtons. So what this means is that if I want to travel at 60 kilometers per hour around a roundabout, which is really fast, the wheels need to be able to generate this amount of force in order to make the turn. This is how much lateral force I need to safely make that turn, correct? However, if you compare these two numbers, right, how much force do you actually have? 1760. How much force do we need? 27,789, right? Clearly, we don't have enough frictional force. True? So therefore, we can say, therefore, since your frictional force is less than your centripetal force, okay, the car will not make it. So in other words, really is correct. Yeah, she's right. Okay, part B. Part B says, calculate the maximum velocity or the maximum speed that the car can go and make the turn. So in other words, this is basically the fastest speed you can travel at before sliding. Okay, so I'm just going to quickly move all of this up so I have more space down below. And then we can have a go at part B. Okay, so how do we calculate the maximum speed before sliding, or the maximum speed that you can travel at? To find the maximum speed, right, just think about the equation. We said earlier that the frictional force, in order to make a safe turn, the frictional force needs to be larger than or equal to your centripetal force. Okay, so that means that the maximum velocity, right, or if you just look at the equation, on the left hand side we have mu mg. It has to be larger than or equals to mv squared on r. Okay. So if you rearrange the equation and solve for v, you can see here how the masses cancel out, and we have v is equals to, v is less than or equal to square root mu rg. So what this is saying then is that in order to make the turn, the velocity has to be less than this amount. Correct? And so that means that the maximum speed that you can travel at, right, and still make the turn, therefore, max speed is when the velocity is equals to mu rg. Okay, does that make sense? And then from here, all you have to do is plug it into the formula, and that's your answer. Okay, so that's how we solve questions involving vehicles traveling around a roundabout. Remember, all you have to do is ask yourself, how much force do we have, right? That's your frictional force. How much force you need, that's your centripetal force, okay? And then compare the two numbers. Similarly, if you want to calculate the maximum speed, right, you just require that, how much force you have is larger than how much force you need. You can see here how the velocity, in order to make the turn, has to be less than or equal to square root mu rg. Therefore, your maximum velocity is given by this equation. Okay, so that's it from me for this video, and I'll see you guys in the next one.